Alright, so we're looking at dividing decimals. We're going to start with 17.63921 divided by 0.045. So you may recall the algorithm for dividing decimals goes something like 0.045 goes on the outside and inside the little house, just like when we talked about division of whole numbers goes on the inside. So long story short, we're taking 17 point all of that and breaking it into 0.045 pieces. I don't really know what that means, but we do have a definition for whole number division. So the algorithm that most people abide by goes something like, I'm going to take the outside and make it not a decimal anymore. What do I have to do? I have to move the little decimal point over 3 times. If I do it on the outside, I got to do it on the inside. So I come up with a new division problem. That's 45 into 17639.21. And now I have division by a whole number, so I'm breaking it up into 45 pieces or groups with 45 elements in each group. I can totally do that division. An alternative to that is just to get rid of the decimals altogether. So if I want to get rid of all of the decimals, what I was dividing by, or the most amount of decimals I have is 5, so I need to move the decimal point over 5 times. If I do it to one of the numbers, I got to do it to both of the numbers. So if I move the decimal point 1, 2, 3, 4, 5 times, I got to do it 5 times on the outside, which if I do it 1, 2, 3, 2 more times, I would just have to add 2 zeros. So I would get 4,500. I think my cat just knocked something over. 4,500 into 1763921. Both of them would give us the same exact answer. This one probably isn't quite so much the norm just because we're dividing by such a big number, but both of them, again, like I said, would give us the same number. Now, why does that work? All I did was willy-nilly move a decimal point around. How can I do that? So let's go back to, these are decimals, so my friend, the decimal fraction. I'm going to rewrite both decimals as decimal fractions and use division of decimals to kind of reason through this algorithm. So 17.63921 is 1763921 over, I got 5 decimals, so 5 zeros, 1, 2, 3, 4, 5, or 10 to the 5th power. And that is divided by 45 over 1,000. Now we just recently talked about dividing fractions. I know I'm supposed to take the reciprocal of the second and multiply straight across. So I get 1763921 over 100,000 times 1,000 over 45. Alright, so multiplying straight across, I get 1763921 times 1,000 over 100,000 times 45. Now, notice I didn't multiply this together. We're going to use the commutative property of multiplication to kind of rearrange and decompose this multiplication again. Ooh, that's all kinds of sideways. Alright, so I'm going to use, again, like I said, the commutative property of multiplication, which tells me that I can switch the order that these two things are being multiplied in. I didn't write any equal signs, but no, these are equal signs all over the place. Equal signs. There we go. All right, so I have 1763921 times 1,000 over 45 times 100,000. And now I'm going to decompose the fraction. So I essentially have this fraction times this fraction, right? If I can multiply them straight across together, I can decompose them straight across apart. I don't think that made sense, but I hope you know what I mean. 1763921 over 45 times 1,000 over 100,000. Now the point of doing that is so I could reduce this fraction right here. So they both have a common factor of 1,000. Shortcut, I'm just going to take all these zeros off. That zero right there. All right, so I end up with 1 over 100. 176 3921 over 45 times 1 over 100. Alright, so here's where the division algorithm for decimals comes into play. I'm going to backtrack because we just did a whole lot of lines of math there. So originally, we took the decimal point, moved it to the right 3 times, and to the right 3 times, gave us 45 going into 17,639.21. So come back up here, see what I have real quick. I have that division of 45, and if I rearrange this one more time, I get 1763921 over 100. Again, using that commutative property of multiplication tells me I can swap those denominators, times 1 over 45. We know from decimal fractions, this number over 100 indicates 2 decimal points, so I have 17639.21 times 1 over 45, which would give me 17639.21 over 45, which is what that standard algorithm tells me. 2 pages of lines with my fractions, but that's how we end up there. That's what tells me that I can move that decimal point 2 times. It all comes down to, or 3 times, it all comes down to the decimal fraction. The other way that we looked at it was just getting rid of the fractions altogether, which landed me with 4,500 going into 1,763,921. We said we kind of stay away from that just because of the big numbers, but it would work the same. And again, that goes back to my algorithm. So if I hadn't have swapped that order right here and just multiplied straight across like we normally would, then I would have ended up with 1763921 over 4,500. So all of those lines of manipulating my fractions and the decimal fractions comes out with the 2 versions of the algorithm we looked at in the beginning. Just moving the decimal point far enough to where the outside number doesn't have a decimal anymore, or moving the whatever one has the most number of most amount of decimals to the right of the decimal point as many times as needed to get rid of all the decimals. So there we go. Decimal fractions.